So I think if you want to learn more about how power systems work, I think one of the best places to start is to look at the mechanical operation of an island diesel genset. They're really simple systems that are intuitively understood. And if you understand how they work, then the mechanics of these systems are applicable to much larger systems like macrogrids that contain coal and nuclear power plants and hydro. It's applicable to how battery energy storage systems operate, and it'll give you the tools that you need to more effectively add solar and wind power to existing power systems. So let's stick with this island diesel genset and understand how it works a little bit better. If you imagine an island that has just one single diesel genset and one little factory and no public grid connection, you can probably already intuitively tell nobody needs to go and tell that genset how much power to produce. In any moment on this system, the loading on the genset is going to be exactly equal to the load of the consumer. So if the consumer is consuming 125.2 kilowatts, our diesel genset is producing 125.2 kilowatts. So the power being produced is always equal to the power being consumed. And there's an automatic adjustment here. If someone adds load at the factory and the power goes up, then the power will go up on the diesel genset as well. And it's automatic in the other direction. If someone reduces loads at the factory, then the loading on the genset immediately goes down to match it. Okay, so we know that an island genset is always producing exactly as much power as the customer needs. But the big question is, how does it know? And for that, I'm going to refer to Kirchhoff's current law. Kirchhoff's current law states that the sum of currents flowing into a point is always exactly equal to the sum of currents flowing out of a point. And the key thing here is that this is always true whether you like it or not. It's a physical reality of the world that we live in. Nobody's got to make it happen. It just is true all the time, no matter what. So if we take a look at our island genset again, we can see that people turn loads on and off as they like. And the genset simply responds to these changing loads through Kirchhoff's current law. And this means that load draws power out of the generator, right? The load is the active thing that's changing, and it's the driver. Let's dive a little bit deeper. And I want you to imagine for a second that we've got a blackout on our island. The diesel generator is on, it's running, but the breaker at its output is open. And this means that there is no power being supplied to the factory, and there's a blackout. So I think we can tell that since the generator's running, we can hear it turning over, and there's smoke coming out of it. So obviously it's consuming some fuel, but it's not producing any power. And the reason for that is that the fuel supply to the generator in this moment is exactly enough to keep the genset spinning at, for example, 3,000 RPM. 3,000 RPM for certain gensets will produce exactly 50 hertz in the frequency of the output power. And that's what we want. We want 50 hertz. So we found the exact fuel rate that spins our engine at that speed. We just learned that if we close the breaker, Kirchhoff's current law guarantees that the load will be immediately supplied. We're probably going to need more fuel. So let's see what happens. We close the breaker, the loads are immediately supplied, and at first, the energy for that load comes not from the fuel, but rather from the inertia of the spinning genset. And as we take that energy out of the spinning genset, it slows down as it loses some of that inertia. The genset has a device called a governor. This can see that the frequency is reduced, and it responds by increasing the fuel rate to try to speed up the generator and get us back to 50 hertz output. Eventually, we're going to hit that nominal frequency of 50 hertz. We might even overshoot a little bit, but eventually we'll stabilize, and the governor will make sure that it's found the correct fuel rate for the current load that the factory has. So when we add a load, the frequency goes down, while the governor increases the fuel rate. And the same thing's going to happen in the other direction. If we remove a load, the frequency will spike up, and the governor will respond by decreasing the fuel rate until we find 50 hertz again. And this means, in general, that we should understand now that changes in load result in a change in frequency. And that's it. What I want you to take away from this lesson is that, number one, demand always equals supply. Kirchhoff's current law ensures that the total power supply always, no matter what, in every single instance is the exact same as the power demand. Nobody has to work to ensure this. It's just true. Number two, this is achieved through the use of inertia first and then fuel. Inertia supplies changes in load, and then the fuel rate is adjusted afterwards. And number three, power and frequency are related. These are the basic building blocks of our power system, and if you understand Kirchhoff's current law and inertia, then you're going to understand very well the impact of adding solar photovoltaic systems, how battery energy storage systems work, and you're really well equipped to understand our national grid at a larger scale. And we'll cover all these topics in future videos. Thanks for listening.